Hi, Algebra. Here's your worksheet video for week 6. We're looking at squares and radicals, prime numbers, simplifying radicals, and reviewing a little bit more about your distance formula. We're going to throw something new about quadratic formula and a word problem. Okay, so first problem says fill in the table of perfect squares. So notice the pattern, 1 squared, 2 squared, 3 squared. You're just gonna go in and fill in for those values, right? You can use a calculator for this. 4 squared is 4 times 4, that's why we get 16. That means 5 squared is 5 times 5, which is 25, okay? So on and so forth. Now we're looking at radicals. So this table is lined up for you to see that pattern. Noticing that exponents are opposites of your radicals or your square roots. So the square root of 4 is 2. The square root of 9 is 3. If I took the square root of 16, I should get 4. So on and so forth. You can also use a calculator for this, but make sure that you're sort of recognizing these patterns and able to do it on your own, being able to identify perfect squares. Okay. Natural number larger than 1 is called prime if it can be evenly divided by only by 1 and itself. So that means, for example, 4 is not a prime because you can divide 4 by 2. You can also divide by 4. You can divide by 1. Okay, so it has multiple factors. It's prime like 3, like 2, 3, 5, because we can't divide this number by any other number other than itself and 1. Okay, so if I went up to the next one, I'd think about 6, but I know I can divide by 2, I can divide by 3, so it's not prime. So 7 can only be divided by itself and 1, so that means 7 is my next prime. Up to you to finish off the rest of the pattern and figure out those prime numbers. Here, we're simplifying radicals, okay? So the fancy thing about perfect squares, like we saw in the table above, is that these numbers are divided by a number that's kind of like doubled, right? 9 is 3 divided by 9 divided by 3 is 3. 16 divided by 4 is 4. Okay? So it's kind of like you're looking for those pairs, those doubles. Okay? So I'm going to use a factor tree to do this. I know that 8 is 4 times 2. 2 doesn't go any lower because that's a prime at this point. Okay? We're not going to do 2 times 1. 4 is split up into 2 times 2. Okay? So now at the end of my factor tree, I've got all these primes, 2, 2, and 2. And I know that here I have a pair, and here I've got some leftovers. Okay, so pairs pull out, leftovers stay. What I mean by this is that if you see a pair of numbers, it's going to come out of my square root, my radical, as just that one number. And if I have leftovers, I'm going to have that radical again with whatever was left over. Okay, let's see it again for 32. I'm going to start with my factor tree. I know, and if you're not confident in dividing or numbers like this, remember that even numbers can always be divided by 2. You can always start small like that, okay? So I'm going to start with 2, just like that. And I know 32 is 2 times 16. And 16 I know is a perfect square. So I can go ahead and say 4 and 4 right off the bat. Even though these can be further factored, it's just going to give you more work if you do so. So I already have this pair and I can be done with that pair. Pulling out that pair of 4, I've got a leftover of 2 because it has no pair, it's a prime. It's going to stay under that square root. Okay. If you have more questions about these, make sure to come to our Zoom meeting where I'll be doing the other problems. Okay. Distance formula you saw from last time, just going to go over really quick. You're just going to plug in where you see the x2, x1, y2, y1. Remember, here's my x1, y1, x2, y2. So very quickly, we will plug it in. X2 is 0 minus a negative 7 squared plus y2 is 0 minus negative 7 squared. Okay. I'm left with the square root of positive 7 squared plus positive 7 squared, because this becomes plus because I've got 2 negatives. So I've got 49 plus 49, because that's what 7 squared is. That means I've got the square root of 98, okay? Now, since we just learned about how to simplify these radicals, I'm going to ask that you do so, okay? We're not going to leave it like this. You're not going to give me a decimal. So we're going to factor tree out, okay? 98 can be divided by 2, and that's going to be 49. And I knew that 49 was 7 times 7. We just did that. And I have a pair and leftovers. So pair gets pulled out, 7 square root 2. Okay, now you're done. Here we've introduced to you the quadratic formula. X equals negative b plus square root of b squared minus 4ac all over 2a. And we use this equation to solve for x when you have an equation that looks like this: ax squared plus bx plus c, where a, b, and c are just numbers. They are coefficients. Okay, so let's start with 13. It's given to us here that a is 1 because when there's no number attached to a variable, there's always an invisible 1. Okay, minus 2k, so that means b is negative 2, minus 63, which means c is negative 63, okay? Signs matter. So we're just going to plug it into my formula here. X equals negative b, so I have negative b, that means I have a negative 2, so that turns it into a positive 2. And I'm going to add that to my square root of b squared, so negative 2 times negative 2 is positive 4 minus 4 times 1 times negative 63 is a negative 252. Okay, that negative came from my negative 63. And this is all in a fraction over 2 times a, which is 2 times 1, so 2. So let's simplify my radical inside. X still equals 2 plus the square root of 4 minus negative 252, so really 4 plus 252, which is 256 divided by 2. Now, 256, I do recognize that as being a perfect square, actually. and that is if I take the square root of 256, it's 16. So I'm going to go over here, 2 plus 16 over 2. 2 plus 16 is 18. 18 divided by 2 is 9. And that would be your x value, okay? So that's how you're going to solve these problems here, these 6 of them. 14, we gave you A, B, C, and again. 15, you're going to find A, B, C, and D, or A, B, and C. Again, 17, 18, your job to find A, B, and C, okay? Now the way to check if this is a perfect square or not is you can start by plugging it into your calculator. If you don't get a whole number, that means it's not a perfect square, and you're going to have to do your factor tree like this, okay? The last one is a word problem, which either you can do on your own or we will do it together in our Zoom meeting class on Tuesday. So if you need help with that, make sure you come in for class on Tuesday. All right. Good luck and have a great week.